Good morning, everybody. Today we are talking about the surface area of prisms. Feel free to follow along in your notes, which should be in the same folder or in your chapter folder for your geometry class. So surface area of prisms. What is a prism? Remember, a prism is a polyhedron with two congruent faces, which are called bases, that lie in parallel planes. So the idea here is we take a polygon. We'll just start with a square or a rectangle. And if we take our polygon, let's start with this corner right here, actually. Start with this corner right here, the blue dot is, and we drag the whole shape. That's going to get annoying fast. We drag the whole shape through space, and then we get another polygon, the exact same polygon, and then now we're going to connect each of the corners. So I'm going to connect the corner that I started with, and all the corners, I'm going to connect them together. And that is a prism. I took a polygon and I pulled it through space and then I connected it back to itself. And this is called a prism, a polyhedron with two congruent faces called bases that lie in parallel planes. Let's refine some of our terminology a little bit more. The bases, the pair of congruent polygons which are in parallel planes on opposite sides of a polyhedron. So we had our polyhedron here. In this case, it's a rectangular prism. The bases are these sides on opposite ends. These are the bases. It's the starting polygon that we pushed through space to make into this three-dimensional shape. Note that these two polygons, called the bases, are parallel in parallel planes, and they're on opposite sides of our prism. The lateral faces are all the other sides, the sides that are not the bases. So once again, let's start with our not my best prism here. So I'll start with the bases that we had last time. These are the bases, the polygons that are the same and on opposite sides. And all the other faces, this face down here on the bottom, this face right here on the side, face on the other side, and even this face right here on the top, those are all lateral faces, just the faces that are not the bases. How can we classify a prism? Well, we're only really going to concentrate on two types of prisms in this unit, and we classify them based on the base polygons. So I've drawn this diagram a couple times now, I'll draw it once more. If we start with a square or a rectangle, say this is a rectangle, and we move that through space, this is a rectangular prism because the base is a rectangle. So if our base is a rectangle, then this is a rectangular prism. Also, we could start with a triangle. Here's a triangle, and we could pull that through space. And then we would have a triangular prism. So here the base is a triangle. So this is a triangular prism. Okay. And now we're ready to talk about the definition of surface area. So we just talked about the bases of a prism, and we talked about the lateral sides of a prism. And each of those sides has an area. So let's look again at our rectangular prism. Here we've got my best rectangular prism. And each one of the sides has its own area. So let's start with just this area of this shape right here in front. That's one of the bases of this rectangular prism. And its area is that of a rectangle. So this rectangle has a length and a width. We know from previous units that the area of a rectangle is equal to length times width. So let's say that this rectangle has a width of 5 and a length of 10. Then its area of the rectangle is just 5 times 10. I'm sorry, it should be 10 times 5, which gives us an area of 50. So is that the surface area of this entire rectangular prism? No, of course not. That's only the area of this first base face. But as you know, there's another base on the other side. But that base is congruent to our first base. The base on the front is congruent to the base on the back. And that means they have the same area. So if we're trying to find the area of our entire prism, we know that we're going to need 2 times the area of this front base. This front base face, whatever its area is, matches the area of this back face. So if we've found the area of the front, then we can just multiply that by 2, and now we have the area of the front and the back. So let's write that in. So we know we need 2 times the base area. Okay, but that does not include all the other sides of our prism, all the lateral sides. So let's look at those now. what about this side right here? Can you agree that if we find the area of that side highlighted in blue, it would be the same as the area of the opposite face, also in blue? Those two faces of our prism will also have the same area, as will, let's do a different color for this one. We'll also need the area of this top piece and this bottom piece. So we need a way to add up all the areas of all these different sides, and when we've done that, we get the surface area of the prism, which is just the sum, I'm going to highlight that, the sum of the areas of the faces of the polyhedron, in this case, our prism. Okay? So fortunately, we have a nice formula for this, and it makes it really easy to solve for the surface area of any prism, any right prism. So just like the prism that I showed you here, the rectangular prism and the triangular prism, this formula will work for both these types of prisms. So let's see how we use this. Well, let's start with our old rectangular prism here. So there's our rectangular prism, and we need to put some labels for the lengths of the sides on here. So let's say that this side length is 5. Oops. This side length is 5. This side length will be 10. And let's make this side length 20. Our formula says that the surface area is equal to 2 times the base area plus P times H. Well, as we know, B is the area of the base. So let's show that. B is the area of the base. There's our base area. P is the perimeter of the base. Let's show our perimeter. Our perimeter is the distance all the way around the base. And H is the height of the prism. So what's the height of the prism? Show that in green. H is the height of the prism. So it's the distance between the bases. So I showed our first base in red, our other base is on the back side. H is that distance between them. That's H. I don't know why it keeps doing that. So there's H. I'll just label that right there. So let's plug everything into our formula here after we figure it out. So we need to find out what base is, B. Base, remember, of our rectangle, of our base area here, is the length times the width of the base. So for this problem, the base area is equal to 5 times 10 equals 50. P, the perimeter of the base, is the distance all the way around our base shape. So we go 5 plus 10 plus 5 again plus 10 again. So our perimeter P is equal to 5 plus 10 plus 5 plus 10, which equals 30. Lastly, we need to find the height. The height is the distance from one base to the other. So here's our front base, and here's our back base. And this green line is the distance between them. And we know that that, oops, is 20. So our height in this case, very easy. All we have to do is say it's 20. Now we have all the pieces of our formula, and we're ready to plug them into our surface area formula. So surface area, S, is equal to 2 times B plus P times H. But we know that B is equal to 50 plus P is 30 times H, which is 20. So we can simplify that, use your calculator. We should get 100 plus 600. Which gives us the final answer of our surface area equals 700. So this same formula works for triangles, and we're going to see an example here in just a minute, but I'm going to do one more example of a rectangle before we do a triangle example. So here we have another rectangular prism, and we need to find the surface area and then classify the prism. Well, we can do that right away. We know that the base faces on this prism, so let's highlight those. The base faces on this prism are rectangles. So there's the front and here's the back. We know those are rectangles. So this has to be a rectangular prism. And then we need to find the surface area, and we know that surface area is equal to 2 times the base area plus the perimeter times the height. So let's start by finding the base, B. Base area B is equal to, here's our base shape right here. So our two dimensions, we've got a 3 inches and an 8 inches, and for a rectangle, all we have to do is multiply them together. So the base area is equal to the length times the width, which for this is equal to 3 times 8, which gives us a base area of 24. In this case, it's inches squared. 24 inches squared. All right, so there's our base. That's one of the things we needed. We also need the perimeter of the base. So again, that's, we start down here in this corner. Start down here. We need to go across once, up, over, and around. So that's going to give us a perimeter of 3 plus 8 plus 3 plus 8, which is equal to what is that equal to? 3 plus 3 is 6, plus 8 is 14, plus 8 again is 22 inches. Don't worry too much about the units. It's more important to get the answer right. 22 inches for our perimeter. And then we need to find our height. And that's the distance between the bases. So we had our front base was here. Our back base is on this back side back here. And the distance between them would be this side or this edge, either one. Any of these. And how far is that? That's 5 inches. So h, that's real easy. That's just 5. So we're going to put that all together now in our surface area formula. Our surface area is equal to 2 times our base, which is 24, plus our perimeter, which is 22, times our height, which is 5. So get out a calculator, make sure you get it right. It's going to give us 48 plus 22 times 5, 110, for a final answer of a surface area of 158 inches squared. Okay. Last problem. We have a triangular prism, but that's okay. Our formula will still work. So our first instruction is to classify the prism. Well, our base here is a triangle. There's our front triangle. There's our back triangle. So we know that this is a triangular prism. Now we need to find the surface area, but our same formula will work. So our formula is the surface area is equal to 2 times the base plus the perimeter times the height. 2 times the base. It's not a very good B, is it? Times, there we go, base plus perimeter times height. Okay, so let's start finding the pieces we need. Let's start with the base area. What is the base area equal to for a triangle? You might have to look back at your old notes from polygons. The area of a polygon of a triangle is equal to 1/2 the length times the width. So for this one, let's look at our base, which we know is a triangle. Here's our triangle. And we've got a length and width of 3 inches and 4 inches. So to find our area, all we have to do is 1/2 3 inches times 4 inches, which gives us a base area of 1/2 times 3 times 4 is equal to, do it on your calculator, 6 inches square. Okay, now we found our base area, we're ready to find our perimeter. So P is the distance all the way around our base shape. So here's our base shape. So the distance all the way around we're going to have to use Pythagorean theorem, because we know that this first side is 3 and this side is 4, but how long is this diagonal side? Well, to find it, we're going to have to use Pythagorean theorem. So I'm going to jump to a new slide, and then I'll come back to this one to find Pythagorean theorem. So we had our triangle base, and we knew this side was 3 and this side was 4, but we didn't know how big this side was. So we're just going to put a variable there called x. We're assuming that our triangle is a right triangle, and we're trying to find the perimeter. The perimeter is the distance all the way around the triangle. So we already know that this side is 3, this side is 4, but we need to find this side. To do that, we're going to use Pythagorean theorem. So let's look at that. Pythagorean theorem, remember, is a squared plus b squared equals c squared. And c is always the hypotenuse, the side opposite from the right angle. So here's our right angle. Where the red dot is. So the side opposite the right angle is our hypotenuse. So we know that x is our hypotenuse. So our sides are 3 and 4. So 3 squared plus 4 squared equals x squared. That gives us 9 plus 16 equals x squared. You can use your calculator. 25 equals x squared. We'll take the square root of both sides, and we find out that x is equal to 5. So we know that x, we just solved for x, found that x equals 5. All right, so now we know the length of that last side, and we'll jump back to our triangular prism. Now that we know what the length of our hypotenuse side is, we know it's 5 inches. And now we can finish finding our perimeter. So the perimeter, the distance all the way around, and it's just 3 plus 4 plus 5. And one more time, where did that come from? We started up here, and we just go all the way around the triangle and add up all the side lengths. 3 plus 4 plus 5. Add that all together. We get 12 inches. So finally, we're ready to find the height of our prism. And we had our first base here in red. There's our first base. Here's our back base in red also. And the height is the distance between those two. So from one base to the other, how far is that? That is 8 inches. So our height, we know that's the easy one here. That one is 8 inches. Okay, we have our base, we have our perimeter, we have our height. We're ready to put it all together in our surface area formula. So our surface area is equal to 2 times our base, which is 6, plus our perimeter, which is 12, times the height, which is 8. So we'll do that multiplication. 2 times 6 is 12, plus 12 times 8. Use a calculator, make sure you get it right, is 96. 12 plus 96, that's our final answer, is, make sure you use a calculator and double check to get it right, 108 inches. squared. Okay, so there's no Go formative for today, but there will be a Go formative posted tomorrow covering all this material. If you have any questions, make sure you email your teacher and check in tomorrow for your next assignment. Have a great day.